I'm Dr. Ingomati, Assistant Professor in Mathematics. In this lecture, we will study about the cumulative distribution functions and marginal distribution functions and their problems. First of all, what is cumulative distribution function? So here, if x comma y is the ordered pair, that is two-dimensional random variables, either it is discrete or continuous, then the function value is equal to probability of x less than or equal to x and y less than or equal to y. That means we have to take a x value, which is something less than or equal to some x values. Likewise, for y is called the cumulative distribution function of x comma y. In the discrete case, we have to use the summations for both the cases that y and x restricted to some values. And in the continuous case, we have to integrate the functions with respect to x and y. Here, focus on this limit. It varies from minus infinity to some particular values of x and minus infinity to some particular value of y. So next we will say about the marginal distribution. Sometimes we are interested in only one variable. The marginal distribution is obtained by eliminating the other variable. For discrete variables, we sum over the other variables, and for continuous variables, we integrate over the other variables. So check it that for discrete case, we have to sum that probability value, that is Pij, with respect to that j value. So it is the marginal probability function of x. For the continuous case, we have to integrate the function with respect to y. So it is called marginal density of x. For marginal distribution of y with respect to y means we have to integrate the function with respect to another variable x. This is called marginal probability distribution. Here the integration formula is given. The probability of x less than or equal to a less than or equal to x less than or equal to b. Here x varies from a to b and y varies from minus infinity to infinity. So we have to substitute these limits. First, we have to integrate the function with respect to y because it limits on minus infinity to infinity. This thing we know that formula. What is this? We have to integrate the function with respect to y means that notation is f x of x, that is marginal probability function of x. Okay, after that, similarly, we have to find the formula for c less than or equal to y less than or equal to d. Likewise, we will apply this formula. Finally, we get that integration c to d marginal distribution function of f with respect to y. Next, we will see about the conditional probability distribution, which describes the probability of one variable when the value of other variable is already known. It helps us analyze dependence between the variables and forms the basis for many statistical models. So that is, we have to find the probability of x by y means the formula is given here. Probability of x is equal to xi, comma y is equal to yi divided by probability of y equal to yj. So this notation is Pij. This one is only j values given, right? So its notation is P star j, which is called conditional probability function. Here, the whole notation is denoted as f of x comma y divided by f y of y is called continuous conditional density of x. This is x given y, and it is denoted by f of x by y. And also similarly, f of x comma y by f of x of y means it's called the conditional density of y given x, and it is denoted by f of y divided by x. Now we will going into the problem. The following table gives the joint probability distribution of x and y. Find the marginal density function of x and y. So the functions are given. What is the marginal density formula? P of x is equal to xi means pi star. That is, we have to add the probability functions corresponding to j. So x is equal to 1, 2, 3. This is y values. This is x value 1, 2, 3. Then what is P of x? We have to add the corresponding x values with respect to j. J means that y values. For 1 means what is the answer? We have to add 0.1 and 0.2. We get 0.3. And for second x value, we have to add these two things. This is 0.4 and this is 0.3. Next, we have to find the marginal density of y means we have to add all the, this is y values, right? All the y values with respect to x. How much y values we have? 1 and 2. So y value equal to 1 and 2. What is the probability of y? So we have to add all these things. 0.1 plus 0.1 plus 0.2. What is the answer? 0.4. And for with respect to 2, we get 0.2 plus 0.3 plus 0.1, that is equal to 0.6. This problem is for your practice. I have given the answer using the above formula. Try to solve this problem. Next, in the example 2, for the bivariate probability distribution of x and y is given below. We have to find the probability of x less than or equal to 1, y less than or equal to 3, something, etc., which is given here. And the joint probability distribution table is also given here. So our x values are 0, 1, 2, y values varies from 1 to 6. Okay, now we will move into the solution. So just I have given the table. First sum, we have to find the probability of x less than or equal to 1 means what is the formula? We have to add probability of 0 and probability of x with respect to 1. Okay, so this is a marginal function, marginal distribution function, right? So this is a discrete function, so we have to use the summation. So x is equal to 0 means we have to add the x equal to 0 values with respect to j. So if j varies from 1 to 6. So that is the formula, j is equal to 1 to 6. P of x equal to 0, y equal to j. Also for in the second term, j is equal to again 1 to 6 with respect to x value 1. Okay, so we have to add all these corresponding probability. The final answer is 7 by 8. Likewise, we have to proceed. Y less than or equal to 3 means we have to add all the y values within 3, that is 1, 2 and 3. Here we have to calculate the y value means that summation value varies with respect to x values, that is I varies from 0 to 2. So again we have to use the marginal distribution formula to calculate these values. And the next sum, both values are restricted. X less than or equal to 1 and y less than or equal to 3. What is that? X less than or equal to 1 means 0 and 1, both the things. Y less than or equal to 3 means within this table, y value 1 to 3. So using these table values, we have to calculate the probability function. Note that here in the other sum, conditional distribution, conditional probability function is given. So that what is the formula? P of x less than or equal to 1, comma, second denominator value y less than or equal to 3, whole divided by probability of y less than or equal to 3. So already we have calculated these values. Just to substitute it here, we get the final answer. Likewise, we have to find the additional probability distribution. Note that here probability of x plus y less than or equal to 4, that means we have to take all the x and y values. We have to add means if value do not exceed more than 4. So likewise we have to do it here. X is equal to 0 means what is the y value? How many y values will come? We have to add these two values means we get 4. That means 1, 2, 3, 4. Because we have to add these values with respect to x. What about x is equal to 1 means 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, 4. So we have to restrict it with respect to 3. Next, with respect to 2 means, x is equal to 2 means we have to add the y values, 2 plus 1, 3, 2 plus 2, 4. So we have to restrict the third term with respect to 1 to 2. Likewise, we have to calculate the summation values. This problem is for your practice. Again, the joint probability distribution function is given. So you have to find the probability of x greater than y. What is that x greater than y means? Check the x and y values. Here x is equal to 0 to 5 and y is equal to 0 to 3. So we have to substitute here. Let us take 0. X value first as 0. 0 greater than 0? No. 0 greater than 1? No. Likewise, it will not come. Next, we move on to 3. Is 3 greater than 0? Yes, right now. Is 4 greater than 0? Yes. Is 5 greater than 0? So we have to take all these values. Likewise, we have to check it for all the x and y values. And finally, we have to add all these values. Next, in example 3. Here also the probability mass function is given and X and Y values are given. X varies from 0 to 2 and Y varies from 1 to 3. And the joint probability function is also given. What we have to find the probability distribution of X plus Y. That means double summation I varies from 0 to 2, J varies from 1 to 3. We have to know the probability values always equal to 1. First, we have to find these K values. So we are adding all these probability values. We get the K value here. Next, we have to find the marginal probability distribution of X, that is I comma Pi star. X varies from 0, 1 to 0 means what? X value is 0 and Y varies from 1 to 3. 1 means likewise, we have to find all the probabilities. This is marginal distribution of Y. Y varies from 1 to 3. Here also, what is the value? Summation I varies from 1 to Pij. So we get the total probability value in both the cases as 1. Finally, we have to find the conditional distribution. So conditional distribution for x given y is equal to 1. So x is equal to I. So x varies from 0, 1 to, but y is equal to 1. That is fixed value. So we will use the formula here. And for x is equal to 0 means what is the formula? 3k divided by total probability, that is we have to add these things, that is 15k, and x is equal to 1 means 5k divided by, we have to add whole thing because y is equal to 1, right? So we will check it for first column, that is 15k, and x is equal to 2 value, that is 7k divided by whole summation value 15k. So their total probability is also 1 here. The other conditional distributions are given below. So this is for conditional probability distribution functions of x given y is equal to 2. The table for y is equal to 1. This table is for y is equal to 2 and y is equal to 3. Likewise, we have to proceed. In first, we have to calculate the conditional probability function of x with respect to fixed values of y. In this tables, we have to find the continuous probability distribution of y with respect to fixed values of x. So fixed values of x means here x value is fixed and we have to vary the y values. So x is equal to 0 is given, x is equal to 1 is given in this table, and x is equal to 2 is given in the table. In all the tables, the final summation value is always equal to 1. That thing we have to check. Finally, we have to find the probability distribution of x plus y. So x plus y means we have x values, y values. What is x plus y? 0 plus 1, 1. 1 plus 1, 2. 2 plus 2, 4. Next 2 plus 3, 5. That thing, that's all only, no. So it comes from 1 to 5. That value is only coming. Then probability function. What is x plus y? P0, 1. P01 means first is x position is 0 and y position is 1. What is 3k? Answer. K value is 1 by 72. We have to substitute it here. And 2 means 1 plus 1 also 2. 1 plus 1 value 5k plus 0 plus 2 also 2, right? 6k. So we have to add these two things, 5k plus 6k, 11k. K value is 1 by 72. We have to substitute it here, 11 by 72. Likewise, proceed it further. Finally, we get the total probability as 1. This problem is for your practice. So in this problem, the joint probability distribution function is given. We have to find all the marginal and conditional distributions. Example 5 is joint probability distribution function of two-dimensional data variable is given here. The function is also given and x and y values lies between some intervals. So it is a continuous function. Here also we have to compute all these probabilities. So it is a continuous function so that we will use the integration to solve the problem. So y varies from 1 to 2 and x varies from 0 to 1. X varies from 0 to 2 and y varies from 0 to 1, we have to substitute here. But in the first problem, they are asking about probability of x greater than or equal to 1. That means in general, x lies between 0 and 2. But in the first question, we have to calculate the x value greater than 1. So the integration is changed to 1 to 2. And we don't want to bother about y value. So we have to take the whole y limit as 0 to 1. So finally integrate this function, we get the answer 19 by 24. Likewise, we have to proceed the another problem is, I will just tell you the traits. Here, probability of y less than or equal to 1 by 2, we have to calculate. Okay, so y less than or equal to 1 2 means here y value is restricted. So we have to restrict that y value only, keep the x value as same. And the second problem, x greater than 1 means x limits are 1 to 2 and y less than or equal to 1 by 2 means y limits are 0 to 1 by 2. After that, the normal integration process only. This is conditional distribution. So first we have to expand that conditional distribution formula. So p of x comma 1 comma y less than 1 by 2 whole divided by probability of y less than 1 by 2. So we already know these values. Just substitute here, we get the final answer. Here, p of x less than y. X less than y is given. So x value starts from 0 and ends from y. So just substitute here and there is no changes in y value. So keep it the limit as 0 to 1. And finally, x plus y less than or equal to 1 means either in limits we have to write either x is equal to or y equal to some value. So change this value as x plus y less than or equal to 1 means we have replaced it as x less than or equal to 1 minus y. So substitute it for x limits. So x varies from 0 to that 1 minus y and keep the y limits as same like 0 to 1. And finally solve the problem. We get the final answer 13 by 480. So these are the tutorial problems for your practice. Here also the continuous function. Wherever you find the interval, you have to solve this problem as a continuous functions. That is, we have to use the integration formula. Thank you.